Welcome to another subtopic, HCF of letters. That is same as algebraic HCF. The way we solve HCF of numbers, similarly, we will do in the case of letters. We should always find a common factor. Example, find the HCF of 3a squared and 12a. Solution. We rule our little table and insert 3a squared and 12a. Then when we look at the 3a squared and the 12a, the common factor that can go in the number aspect of the figures is 3. 3 divide 3a squared, you have a squared. 3 divide 12a, you have 4a. No other numbers can go, but letters can go. A common letter here is A. A going to a squared, you have A. A going to 4a, you have 4. Remember, we are dealing with HCF, so no other common factor can go. So we have our HCF of 3a squared in 12a is equals to 3 times a, which is the same as 3a. Another example. Find the HCF of ax, ay, and ab. The options are given. Option A, small letter a. Option B, small letter b. Option C, x. Option D, y. Option E, abx. Solution. Let us roll our table and bring in the value ax, ay, and ab. Now, when you look at the given values, the common factor here is a. A divide ax will give you x. A divide ay will give you y. A divide ab, b will be left. Now, the resultant value, no other common factor can divide. Conclusively say the HCF of ax, ay, and ab is equals to a. Another example. Find the HCF of 10a squared b and 8ab. The options are given. A, 80a squared b. B, 2ab. C, 5a. D, 1 whole number 1 over 4. E, 4. Solution. Let's rule our simple table and impute the values. 10a squared b and 8ab. When you look at the values, first of all, let us take the number aspect of it. Common factor that can go here is 2. 2 divide 10 will give you 5. Remember to bring down your a squared b. 2 divide 8 will give you 4. Remember to bring down your ab. Now, no other common factor can go in terms of the numbers. So we look at the letters. A can go conveniently. So when a divide a squared b, you have ab. Bring down your 5. Then a divide ab, you now have b. You bring down your 4. Now the resultant value, if you study carefully, you will observe that b is also common to the two values. So b divide 5ab, you now have 5a. B divide 4b, you now have 4. You can conclusively say, since no other common factor can divide, that the HCF of 10a squared b and 8ab is equals to 2 times a times b, which is equals to 2ab. Another example. Calculate the HCF of 15a, 12a, and 14a squared. The options are given. A, 15a squared. B, 3a. C, 2a. D, a squared. E, a. Solution. Let us draw our table. Yes, we input our values into the table. We have 15a, 12a. They also put 14a squared. When you look at our imputed values, you observe them carefully, you will see that the number aspect, we have no common factor. Then we now switch to the letter aspect. The letter aspect of the given values. A can divide through. So when you take A divide 15A, you will now have 15. A divide 12A, you will now have 12. A divide 14A square, you will now have 14A. That is the only resolving that we can do. No further number or letter can divide through. So we can conclusively say the HCF of 15A, 12A, and 14A square is equals to A. Another example. Find the HCF of 18A square Y and 27X square Y square. Solution. Let's rule out our table and impute given values. 18A square Y and 27X square Y square. Looking at the letters first, let's take the letters first this time around. The common letter that can divide through out of the two given values is Y. When Y divide 18A square Y, you will now be left with 18A square. When Y divide 27X square Y square, you will now be left with 27X square Y. The resultant value, there is no other common factor that can divide through in the letters aspect. But when we come back to the numbers, looking at the numbers, 18 and 27, 3 is a common prime factor. 3 divide 18, you will now have 6. Remember to bring down your A square along with it. 3 divide 27, you will now have 9. Remember to bring your S square Y. Now, looking at the resultant value, we're still looking at numbers this time around. You see that 6 and 9, 3 can still divide through. So we use 3 to divide. And 3 divide 6A square, you now be left with 2A square. 3 divide 9 will now be giving you 3. And you bring down your S square Y. And no other letter can divide through. So conveniently we can say HCF of 18A square Y and 27X square Y square is equals to Y times 3 times 3. And that's the same as 9Y. Another example. What is the HCF of 8AB square C cube, 6A square B square, and 10AB square C square? The options are given. A, 8AB square C cube. B, 10AB square C square. C, 2AB square. D, 120A square B square C cube. E, 2AB square. Solution. Let's rule out our table. Let's impute our values. 8AB square C cube, 6A square B square, 10AB square C square. Now when you look at the given values, you will observe that in the number section of 8, 2 are a common factor that can divide through 8, 6, 10. So we use 2 to divide first. 2 divide 8 will give you 4. You bring down your A B square C cube. 2 divide 6 will give you 3. You bring down your A square B square along with it. 2 divide 10 will give you 5. You bring down your A B square C square along with it. The resultant value, no common factor number wise that can divide through again. So we stop in terms of numbers. Now we start observing the letters. The letter aspect, starting with A can divide through. So A divide through. In the first case, you will now have 4B square C cube. In the second case, you will now have 3AB square. A square will now be reduced to A then. Now, in the last case, you will now have 5B square C square. Now, looking at the A aspect in our resultant value, A is no longer a common factor. So we now switch over to B. B can divide through. We take B, the B square will now be reduced to B in the first case. And you still bring down your 4BC cube. In the second case, B will divide B square will now be reduced to B. So you still bring down your 3A along with the B. Now, in the third case, the last one, B divide B square will now be reduced to B. You still bring down your 5 along with the B and C square. When we observe our given resultant value now, B can still be a common factor. B divide B will now be reduced to just 4C cubed. Then the second value 3AB, when B divided, you will now be left with 3A. And the last value 5B squared, when B divided, you will now be left with 5C squared. No other common letter can divide through. So we can conclusively say that our HCF value will be equals to 2 times A times B times B, and that is equals to 2AB squared. As we've come to the end of these examples on this subtopic, HCF of letters, or algebraic HCF, we took some exercises from page 65 of our book, Hidden Facts in GSSE Mathematics. The exercises, you try your hands on them. Answers are provided at the end of the book, either the hard copy or the soft copy. Thank you.